Alright, we're going to go over related rates really quickly. And related rates can seem difficult at times just because most of the time there are word problems. But it's not that difficult. Usually if you just read the problem out and find out what it's asking for, they can actually be pretty simple to solve. So best way to do related rates is to just jump right into example problems. And so we're going to go ahead and do that. And the example problem that we're going to do is read as this. It is a heap of rubbish in the shape of a cube is being compacted into a smaller cube. Given that the volume decreases at the rate of 2 cubic meters per minute, find the rate of change of an edge of the cube when the volume is exactly 27 cubic meters. Alright, so that's the problem. First thing you do whenever you have a related rates problem is go ahead and try to figure out what a formula you can use is. And this one is talking about a cube and it's talking about volume. So we automatically know it's asking us what the question is asking is for the rate of change of an edge of the cube when the volume is exactly 27 cubic meters. So we can first begin by putting down what the formula for the volume of a cube is. So we know that the volume of a cube is equal to length times width times height. But since it's a cube, they're all going to be the same measure. So we can just go ahead and say side cubed. And that is the formula for a volume. Now, if you look at the problem, again, you can see that it gives us a couple of givens. Like the volume decreases at a rate of 2 cubic meters per minute. What is the rate of change of the edge of the cube when the volume is exactly 27 cubic meters? So we know that we are looking at the rate of change, and when we're looking at rate of change, that means we can go ahead and look at the derivative, because that's what the definition of derivative is, rate of change of something. So we need to go ahead and figure out what the derivative of this formula is, and we're doing it in respect to time because it's changing every so often. It changes 2 cubic meters per minute. So we can go ahead and say, okay, the derivative of this formula will be dV over dt, the change in volume over the change in time, is equal to, and you should know how to do derivatives, you just bring the 3s squared times ds dt, because that's what we're solving for. We're solving for what is the rate of change of each side as time keeps going. So, and this is called implicit differentiation. Normal differentiation would just have us ignore the ds dt and just have us do 3 squared. But since we're doing this in respect to time and not in respect to the edge, we have to also include the ds dt, which is the change in edge as time goes on. So now that we have basically this formula, all we really have to do is look at the problem and plug in the numbers that they give us and solve for ds dt. So again, if we look at the problem one more time, we'll see that they said that the volume is decreasing at a rate of 2 cubic meters per minute. Decreasing means that it's going to be negative because it's going down. So we're going to go ahead and go say that our dV dt is negative 2. And it also said that what is the rate of change of the edge of the cube when the volume is exactly 27 cubic meters. So it doesn't technically give us a side or the length of the edge or the length of the side. So we'd have to infer this. If you look at the problem, it says the volume is 27 cubic meters, and since you know that it's a cube, you know that each side has to be the same length. So just the cube root of 27, which is 3, and so then you know that the side would be 3. And that's how you figure out what the side is. So, I mean, sometimes when you have related rates problems, they won't outright tell you what to plug in, but they always give you the information for you to be able to figure it out. And it shouldn't be too complicated. So, we can go ahead and plug 3 in for our side, or s. And now we're just solving for ds dt using algebra. And go ahead and simplify this to negative 2 equals 3 squared is 9, 9 times 3 is 27, ds dt and then we just divide the 27 over. So we have negative 2 over 27 equals ds dt, and that would be our final answer. So basically what this tells us is the rate of change of each side as the volume is decreasing at a rate of negative 2 cubic meters per minute is negative 2 over 27, which makes sense. And that is related rates in a nutshell.